Guys, how's it going? This is Ebetuba. In this video, I'm going to introduce you to elimination method, just like I promised you in the previous video. Okay, so this one will be very defining in terms of how you're going to answer your Cambridge or your ZIMSEC exams. Okay, so these are one of the elimination method, simultaneous equations. It's one of those things that you can apply and actually get really good marks. And then if you listen really attentively, it'd be an easy score for you. Okay. So the elimination method, we have several steps. Again, I don't want you to commit the steps to memory. I want you to just go over them, but then you actually understand them more in depth when we will be doing actual learning. Okay, so the step one is this is step one. Okay, so you're supposed to arrange the equation to match the corresponding terms. So you know about this very soon, but then essentially your terms would be in x, and then you'll be having terms in y. Okay, so you're supposed to arrange them in a way that's corresponding. I will teach you how to do that very soon, and you're supposed to match the magnitudes of the coefficients of either y or of x in the equation. Okay, so this is how we eliminate the equation. Okay, so we were supposed to eliminate one of the terms by adding or subtracting. I'll tell you when to apply which as soon as we start doing our examples, and then obviously you solve the remaining linear equations, equation using the simple tactics for solving linear equations that we did previously. And then you use the method of substitution to get the other variable. It's important for you to know that you're supposed to get the value of x and the value of y in your working. Okay, so elimination method, you're solving for two terms. You're solving for x and you're also solving for y. So the elimination method of solving equations, it's generally the simplest method that you can use. Okay, so unless you're specifically instructed to use any other methods, I strongly advise you to use the elimination method. Okay, so it's the easiest method. Usually it computes the answer the fastest. So I really encourage you to use that one. So let's go to our examples. So you have this, you're asked to solve the system of simultaneous equations. I'm going to teach you how to do it when eliminating y and also when eliminating x. Okay, so I'm going to recall my guidelines here and then just have them handy so that you understand a bit more on how it's supposed to work out. So here you have y and y, so you arrange the equations to correspond to such that the terms are corresponding. So here you have this one in x, so you see this one is up and then this one is down, which is good. Okay, so they are in the order of x and also y, and also just the numbers, so that you need not apply the step. This step is applied already. And then you're told to match the magnitudes of the coefficients of either x or y. So here, most of the times you actually have to be tactical about it, because some coefficients, they are easy to match than others. For this case, the coefficients were matched for y. The coefficient for y here, it's just 1, and then the coefficient for y here, it's just 1. Okay, so you need not apply the next step here. So you add or subtract the terms, corresponding terms for the matched. Whenever you match the magnitudes, you add or subtract. So here, if the signs are the same, you're supposed to subtract. So the signs for y and for y here, they are both positive, so you subtract. What is it exactly that you're subtracting? Okay, so here now the game starts. So what you do is you put the squared bracket here. Okay, so I'm going to put this squared brackets, and then I'm going to say subtract like this. Okay, so this is how you go about it. And then when you subtract, you're subtracting the corresponding terms. This is a big reason why we actually had to match the terms to begin with. So this is how you do it. So you say 4x minus 2x. Okay, so notice that I'm going to my term here. So I'm actually going to my term. I'm going to my term here. Okay, and then I'm going to my sign here, and then I'm going to the other term here. This is specifically important when you really want when you're dealing with negative signs, or when you're dealing with multiple signs. Okay, so here I'm going to say 4x minus 2x, then I get 2x. Okay, then I'm going to say y minus y, then I get 0. This is the reason why we were subtracting here. When you have the same sign for the merged coefficients, you subtract. This is how you get rid of the one of the terms. So in this case, we're getting rid of the y. So you actually need not write anything here because it's just 0. If you want, you can say plus 0. It's still fine, but then you need not write anything there. So now you're going to say 17 minus 9. 17 minus 9, what do you get? You get 8. Because 8 plus 9, you get 17, okay? This is just a linear equation which you can solve easily, okay? So here I'm going to divide both sides by 2. That's how I get rid of this 2 here. So I get x equal to 4, okay? So this is it. I get x equal to 4, and I can also do the I can also take one of the math. You're supposed to be tactical about this because usually one of the equations will be harder. So for example, this one has 17 in it and it's got 4x in it. So I don't really want to take this particular equation. I'm going to take the next one here. So what I'm going to do is to recall this equation. So it's actually 2x plus y equal to 9. I'm going to substitute the value of x here. So I'm going to say 2. Then 4, just because I know the value of x already, I just want to know the corresponding value of y. So here I'm going to get 8 plus y equal to 9. Then I'm going to get y equal to 9, then minus 8, 9 minus 8, then I get 1, okay? So the way that I would write it, all right, my conclusion would be x equal to 4 and y equal to 1, like this, okay? So this is how you go about doing elimination method, and note that I'm just going to put my answer here, okay? So because we want the answer as a reference, and what I was gonna say was that note that you need not match for y. Sometimes you can match for x as well. Here the coefficients for y were matched already, so that's why we didn't need to match the x terms. Okay, so I'm going to do the more difficult thing here and actually match the terms in x. Okay, so the terms, they are rearranged such that they are arranged such that the terms in x and the terms in y, and then the numbers, they're in corresponding order. So you get x here, and then you get y's here, then you get numbers here. Okay, so this is very beautiful for us. And what we want to do is to match the magnitudes of the coefficients for x. We said we'll do the more difficult stuff. Okay, so now we want to match 4x and 2x. We want to match them to a magnitude. Okay, so here 4 and 2, we're looking for the most immediate number that we can find for which 4 and 2 are factors. Okay, so it would be 4. So 4 would be what we call the lowest common multiple, just like we did in one of the previous topics. Okay, so we're looking for the lowest common multiple. In other words, also one way to think about it is if you had denominator 4 and you had denominator 2, what would you put as your common denominator? Obviously before, and then you have to strategize to say, okay, what can I do to this 2 in order to create 4 there? So I have to multiply this one by 2. So if you multiply this one by 2, remember you're supposed to multiply each and every term. That's how you keep your equality. Okay, so in the first step, I'm going to write this R here. It's a very beautiful R. As you can see, it just shows that we're skipping to this part here. So what I'm going to do is, this first equation, we're not going to touch it because it's merged already. It's 4x. Okay, so this is really what we wanted, so we're not going to affect it in any way. But then this one, we're supposed to bully it to multiply it by 2 so that we form our 4x there, so that we can prepare for the process of eliminating x. So here it would be 4x here, and then y it'd be plus 2y. And then it'd be 9 multiplied by 2, 9 multiplied by 2, then you get 18, like this. Okay, so after this, now you have matched the coefficients for x. So what you do next is you're supposed to eliminate x here. And we say that, remember the step, on step 3, we say that if the corresponding terms have the same signs, what we do is that we'd subtract. So here you are having 4x and 4x, so you're going to subtract. So how would you subtract? So you'd put this square brackets here, very big square brackets. These square brackets, they're important in that they remind you that you're supposed to subtract each and every term that's present in this square bracket here. So you'd say 4x minus 4x, we're going to get 0. We're not going to write that 0 because it's unnecessary. That's how we eliminate. And then here you're having y minus 2y. What do you get? You get negative y. Okay. One way to think of the same thing is 1 minus 2. What do you get? You get negative 1, obviously. And then we're also going to do the same thing for 17 and 18. 17 minus 18. What do you get? You get minus 1. Okay. And then to get y here, you're supposed to divide by -1. So we're going to divide by -1 and you get y equal to 1 like this. And notice that this value of y that we're getting, it's also the same value of y that we got previously. So which is great, okay? And it shows that we're doing the right thing. Now we want to find the value for x. Remember I told you that the second step, it actually borrows from a method of substitution that we're going to do later on. But then what the essence of it is that you're supposed to choose either this one or this one. You're supposed to choose one of the equations, choose the simpler one. The equation that computes the x value the fastest. So it'd be the second one here because it's simply 2x, and then the other one it's 4x. So we don't want that. And then also avoid using these these changed equations. Okay, you don't want to use them because they're usually bigger and bulky. Okay, so here what we're going to do is to substitute the value of y because we know the value of y already. So the value of y, we're told that it's 1. Okay, so here you'd be having 2x plus 1 equal to 9. So you'd be having 2x equal to, then this one would be 9 minus 1. Then you'd be having 2x equal to, then this one is supposed to get 8. If you're using a very big piece of paper, then you need not go to the side as I'm doing. Okay, so I'm actually running out of space. That's why I have to use this other space here. But then if you just arrange your stuff with the equal signs in a straight line, that makes for great presentation. Okay, that's a very good way of presenting your stuff. So I'm going to divide by 2 here. I get x equal to 4, just because 8 divided by 2, I get 4. Okay, so I'm going to say, therefore, this is how I conclude my equation. I say x equal to 4. And y equal to 1. Okay, so like this. Okay, and then I just put my beautiful arrow again, just like this. So this is how you work out the equation. And notice that you could have eliminated y, which we did in the first when I was showing you the first time, and then you could also do the same thing for x. But then when you see how we worked it out for x, we had this extra step where we're supposed to multiply by this 2 here. Okay, so you want to avoid that. So that means that when you are approaching an equation, a system of simultaneous equations, you're supposed to have foresight on which should I eliminate. Should it be the y or should it be the x? And you're supposed to eliminate whatever is easier to eliminate there. Okay, so according to how you can match the coefficients. Don't worry if you didn't get so much of this. Okay, so we're actually going to work out another problem where you're going to see more or less what we're talking about here. So the first step here, it's now necessary. See how this one is arranged. It's y then equal to 2x minus 5. We don't want that. We want it such that the y is there, they're top down, and then the x is there top down, and then the numbers, they're also top down according to the position of the equation. So there are so many ways to go about doing this, and I'm going to show you the easier one. So the easier one would be to just get the first equation as it is, and then you try to adjust the second equation. So the second equation here, the first equation only has y on one side of the equal sign. So you also want this one with the coefficient with y on one side of the equal sign. So here I'm going to leave -2y. Remember when we did the one of the first topics, we said that a number owns the sign to its left hand side. So this is why it was important. Okay, so it would tell you that you're supposed to leave -2y here and not just 2y. And then 7x, you would skip to this other side here. So you'd actually get -7x. Okay, so you get -7x plus 16. There's already plus 16 that's there. So now you've matched your values. Now it's up to you now. You can choose which one to match. Okay, so which one is easier to match? So you may have guessed it right. Okay, so the one that's easier to match, it's actually the term in y here. Just because the lowest common multiple is just 2, so here I just need to multiply this one by 2. Of which for matching the x values, I have to multiply this one by 7, and I also have to multiply this one by 2. So it's not very efficient. Okay, we are going to use the other method, the harder method later on. But then in this case, we're going to use what you're supposed to use in the exam, which is the simpler way to go about it. Okay, so here I'm going to multiply each and every term, remember the square brackets, they remind you that each and every term in there is supposed to be multiplied by the scalar here. Okay, so 2 multiplied by 2 by y, you get 2y, and then 2 multiplied by 2x, you get 4x here, then you get minus 10, like this. I'm also going to just rewrite this one because we didn't need to change anything there. So it's going to be negative 2y, then negative 7x here plus 16, which is great for us. Okay, now that we are done, we have matched the coefficients. We have matched the coefficients. We chose to match the coefficients for y, so which is great for us. And notice, yes, you know, I didn't talk about it much, but then this arrangement is actually different from the arrangement that we had previously. You're not supposed to be religious about the arrangement. You're just supposed to have the arrangement be the same. If you want the equations, the terms in x and terms in y, and also the number to be on the same side, it's up to you. Okay, the arrangement just has to be the same so that we can subtract or add as is appropriate. Okay, so in this case, we say that we subtract when the corresponding terms have different signs. Okay, so the corresponding terms, in this case it's y, they have different signs, so we're supposed to add. So okay, so this one it's written wrongly. When you have different signs here, what you're supposed to do is to add. Okay, so for different signs we add, and then for the same signs we subtract. Okay, so here for different signs, I'm going to say 2y, then minus 2y here. So plus and minus, I just get minus. So here I'm going to get 0. This time I'm going to write 0 just because I cannot just leave the left-hand side without any term there. Okay, so that it becomes an equation. I have to put a number here. So I'm going to also do the same thing. So say for 4x plus minus, I get minus. 4x minus 7x, what do I get? I get 4 minus 7, essentially I get negative 3x here. So here I get negative 10 plus 16. So negative 10 plus 16, what do I get? I get 6. Okay, so it's as if negative 10 plus 16, I get 6. So I'm going to throw this number here, it's going to come to the side, so I get 3x equal to 6 like this. I can actually just straight up divide by 3 this time. So divide by 3 here, divide by 3, I get x equal to 2. Like this. Okay, so which is great for me. And now I have to set in the value for y. So I take whichever is easiest. We said the easiest one for this case would be the first one. So the first one would be 2x minus 5 like this. And then you have your value of x. Your value of x is actually 2. So you have 2 by 2 minus 5. Then you get 4 minus 5. Then 4 minus 5. What do you get? You get negative 1 like this. Okay. So I'm going to conclude. I'm going to say therefore my x equal to 2 and my y equal to negative 1 like this. Okay, and that's it. Okay, so you have done right, and what I'm going to do is to just record this answer, and then we do the same problem, but then this time we'll be doing it the other way. Okay, so if you're asked to do the same problem, you're just supposed to do it this way. It's easy for you to eliminate y for this case, but then we're going to try to eliminate x, okay, and see what happens. So when we try to eliminate x, the procedure for the first time, it's always the same, and right now let's try to mimic the procedure for the second one. Or we can just do the same thing that we did previously. It's still fine. Okay, so we had 2y equal to 2x minus 5. It's still fine, just like this. And then we were supposed to match this one, so we said it'd be negative 2y equal to, then this one would be negative 7x, and this one would be plus 16 like this. Okay, so what we want to do is to eliminate the terms in x, which is the harder way to go about it. So the common denominator, if you were working out it, if you're working it out as a fraction, would be 410. If you want to think of it as lowest common multiple, it'd still be 410. And then you'd think, now how would you arrive at 410? So it'd be by multiplying this one by 7 here, and then by also multiplying this one by, you'd multiply this one by 2. Okay, so what do you get? Remember the square brackets, they remind you that you're supposed to multiply each and every term that's in there by the scalar. So the scalar would be the 7 here or the 2 here. Okay, so you multiply 7, multiply by y, then you get what? You can put this arrow here, which is a great arrow to use. Okay, so it simply means that we are now skipping to this step. So you get 7y here, then 2 multiplied by 7, then you get 14x, then minus 35 like this. And then you also do the same thing with this 2 here. So 2, this column multiplies everything in there. So you get negative 4y equal to, here you get negative 14x, here you get plus 32 like this, okay? So I'm going to put my big squared brackets here. My big squared brackets, I'm putting them to prepare to add or subtract as is appropriate. So here we're supposed to add just because we have different signs. When you have different signs, we are supposed to add. And if you just know your directed numbers very well, then you actually don't need to cram whether we're supposed to add or subtract. Okay, you can actually see that 14x here, in order for you to eliminate x, you're just supposed to add y, because it becomes 14x minus 14x, then you just get 0. For the first term here, you'd be saying 7y, then minus 4y. So 7y plus minus, you get minus. So 7y minus 4y, what do you get? You get 3y here. So 14x minus 14x, you just get 0. Okay, so you can write 0 if you want. You can just leave it like that. It'll still be okay. So here you get negative 35 plus 32. Negative 35 plus 32, you get negative 3, okay? And then here you're supposed to divide. Obviously you're going to divide by 3 both sides, and then you get y equal to what? Equal to negative 1 like this, okay? So which is great for us. And then now you're just supposed to compute the value for x. So you can choose the equation that's simplest. I'm going to choose this one here, okay? So I'm going to choose y equal to 2x minus 5, and then I'm going to substitute the value of y. So y is equal to minus 1 here. It's equal to 2x, just 2x. Okay, just 2x minus 5, and here I'm going to leave 2x here. This one I'm going to kick it over to this side, okay, to transpose it. This one will go on to become positive, so it'd be negative 2, it'd be negative 1 plus 5, okay? So you'd actually get 4 here equal to 2x. Then you divide both sides by 2, then you get x equal to 2. And notice that so you can conclude, therefore x equal to 2 and y equal to negative 1 like this, okay? So now we're going to introduce an interesting twist to it. So we are sure that our equation now, because we worked it out using by eliminating the other one, and then we changed up, and then we said we'd do the more difficult stuff and eliminate this other one, and then we still got the same value. Now we're going to add another layer to it. This one is interesting, okay? So this is what you do after you have done your exam very well. Remember, I know that, you know, with practice and stuff, so you'll be able to finish your exam on time. And then when you have excess time now, you can come back. Simultaneous equations, that's one of the first topics that you really want to go and then review. Why? Because you can actually see whether you've done the right thing or not. So for simultaneous equations, here is how you do it. So here, these are my values. Let's say I've worked it out, and then I got this one, and then I just want to cross-check or to verify whether I've done the correct thing or not. So y here, y is equal to what? Y is equal to negative 1. So I'm going to use this equation here. So 2x minus 5. Substituting for y is equal to negative 1 here. That's what I think. So I want to see whether it actually works. And x is equal to 2. So minus 5 here. So I get 4 here minus 5. And I get minus 1 equal to 4 minus 5. I really get minus 1. And I'm happy about this, just because minus 1 is actually equal to minus 1. If I had gotten any other value here, it would have been difficult for me to actually get the true answer, okay? And then the other critical thing that you're supposed to be aware of is that you don't just test for one equation. So we tested for this one equation, but then you don't actually just test for that one equation. You can also test for the other equation. You should also test for the other equation. So we are going to use the second equation as well to see whether we have done the correct thing. So I'm just going to write the second equation as it is, and then I'm going to substitute my values. So for x is equal to 2, and then for y it's equal to negative 1, and then here it's saying it should be equal to, if I'm correct, it should be equal to 16. So here I'm going to say 410, obviously 7 by 2 I get 410, then minus 2 times minus 1, then I get 2, and then here I get 16. And indeed 16 is equal to 16 like this, okay? So this is how I verify after writing my answers. I want to actually show you. Let's say we had gotten 2 and let's say 0, okay? So you'd be let's say you made some mistake somewhere, and then you get 2 0 here. What you have is you'd have y equal to 2x minus 5, and then you'd have your y equal to 0 here is equal to 2 multiplied by 2 minus 5. Then you'd have 0 equal to 4 minus 5. 4 minus 5, you get negative 1, and there is no way 0 is equal to negative 1. That means you have done a mistake somewhere. Okay, so if you're actually revising it in an actual exam situation, so what you do is don't cancel out your work before actually working something else out. Okay, so you'd work it out on another piece of paper. I don't know how you'd go about it, but then on another piece of paper you can write your math, and then once you're done you can go ahead and cancel this previous one. And then also just be careful. Sometimes maybe you actually made some mistake in verifying your answer. Okay, that's essentially it. This is why I was telling you that the method of elimination is the best method that you can ever use. Okay, so that's just about it. I'm going to show you, I think we could use another example. Why? Because this is just a great way of getting your scores straight, because these are just easy marks to have. Okay, so I'm going to use this one, this equation here, to actually apply again the method of elimination. I'm not going to put those steps. Those steps were like they were like railguards. These were the stuff that we're using when you didn't know very well. But then now I actually trust that you are actually getting it now, and it's better for you. So here you can actually pause the video and then see which one you'd want to match between these two here. So here there's another trick that you can use. The trick would be to realize that here 2 it's a factor. Okay, so 2 here it's a factor. You can use that trick. Sometimes it can give you really easy ways of working it out. So for example, here you'd read 4a minus b equal to 4a minus b equal to 3, like this. Okay, so it would read 4a minus b equal to 3. This is more comparable to 10a plus 7b equal to 36 in terms of matching, just matching the brackets. In fact, let's just use this one. Okay, so this equation here, I transformed it just like what we did previously when we were multiplying by sometimes a scalar, and saying that if we multiply every term in that equation, it won't change the value of that equation. It's also the same thing here. You can divide by a certain factor as long as that factor is consistent with each and every term there. As long as you divide through and through, that means you will not have changed the value of that equation. Okay, so the way that you go about it here is to try to figure out which ones should you match. Should you match the terms in X, the terms in A this time, or the terms in B? If you got a hang of it already, then you must know that here you're supposed to match the terms in B, just because they are the simpler ones to match. You just have to multiply this one by 7 and then leave this one alone. Okay, so it'd be good for us to multiply this one by 7. So if you multiply this one by 7, you're getting 28 a here. Remember, the square brackets, they are a guide for you to actually multiply everything else in the bracket. Okay, so everything in the bracket is supposed to multiply it by 7 here. So here I'm going to get negative 7b, and I'm going to get 21 here, which is great for me. And then here I'm going to get 10a, then plus 7b equal to 36. And then the next step would be to compare the signs for the matched coefficients. So the matched coefficients, it's negative 7 and 7 here. So if there are different signs, we say that we can actually just straight up add. Sometimes you don't have to cram exactly why we're doing this, but then essentially we're doing it to eliminate the value of b here. So obviously if we add, then it makes sense, because negative 7b plus 7b would get 0. Okay, so it's always important for you to be conscious of what is it exactly that we are doing, because it can become a guide for you to work out and get the correct answer. So here I'm going to add. If I add, then I get 38 here. I'm getting 38a, I'm sure. And then here I'm getting just 0. So we say that the zeros, we can just leave them like that. Okay, as long as there's something representative of that side of the equation. So left hand side, I'm going to write 38a here, which is great for me. And then for this one, I'm going to write it's 21 plus 36, so it's actually 57. Okay, So I'm going to write 57 here. So now 19 is actually a factor here, so we can divide both sides by 19. Okay, so you divide this one by 19, you divide this one by 19. So here you get 2 and here you get 3. Okay, so here I'm getting 3. And then you get 2a equal to 3. So that means a equal to 3 over 2 like this. Okay, so which is great, just like I told you in the very introduction for simultaneous equations. We say that the answers they can also be fractions, they can also be decimals. It's still fine. Okay, but then when you're getting weird numbers like 11 over 19 or something like that, it usually means that you're getting something wrong. Okay, especially ZIMSEC, because they give you affordable numbers. Okay, so 3 over 2, it's really conceivable, it's still fine. Okay, so we can say this could be the answer. And then we're going to do the same thing for that we did previously. We say that in the next step we're going to use substitution. So you take whichever equation is easier to substitute for. So you can use this one. You can use this one, this version of the equation here, or you can use this version of the equation because this one was simpler. Okay, so I'm going to use the second one. So it's going to be 4a minus b here equal to 3, and then we already discovered that our a is equal to 3 over 2, so I'm going to write 3 over 2 on a here, and then minus b equal to 3 like this, and then see what comes off. So here I'm going to 2 into 2, 1 into this, I get 2, then 2 multiplied by 3, I get 6, then minus b equal to 3 like this, then I'm going to kick over b to the side and then 3 to the side. Okay, so it becomes 6 minus 3 equal to b, so obviously b is equal to 3. Okay, so I'm going to write, therefore, this is how I conclude. I write a equal to 3 over 2 and b equal to 3 like this. Okay, so this is good for me. This is good for me, and I'm going to record my answer just in case. Okay, so I'm going to record my answer is we said a is equal to 3 over 2, so this is a, and b is equal to 3. Okay,